Hopefully you can all hear me clearly. Today we're going to discuss some energy efficiency for greenhouses, specifically heating and cooling systems. So we're not going to go into things like lighting or irrigation, but specifically look at greenhouse heating and cooling and some energy efficiency options, kind of what the standard is and what those better steps are. So hopefully this is going to work. There we go. Okay, so we are working. Kind of a quick presentation overview is we'll start out with talking about boiler systems and different options for using boilers, talk about unit heaters. So we'll start out with the heating side of the presentation, and then we will move into the cooling side, which will look at natural ventilation, mechanical ventilation, and then moving from mechanical ventilation into evaporative cooling. We'll also talk a little bit about refrigeration because that is one of the cooling systems that is out there for some greenhouses. And then we will wrap it up and discuss a little bit of funding information and answer any questions. But as Julia said, feel free at any time to type in a question for Julia and myself. We'll try to answer them as we go through the presentation here. So, quick question to start out the webinar today. True or false question for you. Greenhouse energy consumption can be modeled using standard building models. I'll give you just a minute to think about that. Hopefully we've all answered false. Although there is a lot of building modeling software available out there, a greenhouse is not your standard building, so we would not model it with typical building software. There are some options out there, such as Virtual Grower. There is a USDA NRCS free energy self-assessment tool online that you can try. Otherwise, it really needs to be done by somebody who has understanding of greenhouses and the differences between greenhouses and the typical building. The trickiest part with greenhouses is usually that we have to account for solar insolation. So all that sunlight that's coming in and creating extra heat for us, as well as the fact that we are building these with plastic type materials and the amount of infiltration losses that typically occur with a greenhouse because we've got fans, we've got louvers, we've got opening and closing sidewalls, maybe ridge vents. So those are some of the things that we have to take into account that typical building software does not take into account for us. So outside of labor, our biggest cost for a greenhouse is typically going to be our energy bills. And most of that is going to come from heating. A little bit will come from electricity. But overall, the amount of that is going to depend on what is the use of the greenhouse. Is this a high tunnel house? Is this used seasonally? Is it used year-round? What crops are we actually growing in that house? So our best practices for greenhouse heating efficiency is going to include temperature controls, thermal curtains or thermal blankets, underbench heating, good insulation, good glazing material, proper glazing material, potential for heat recovery, and we'll discuss that a little bit more. There's a lot of things that we can do to maximize our energy utilization in greenhouses. So we're just going to touch, like I said, on the heating and cooling systems today. We do work at GDS with producers on things outside of just heating and cooling. This slide and the next slide here kind of gives us a little bit more information on what other things we look at. We might look at lighting, we might look at refrigeration systems, we might look at irrigation systems, we might look at actual building utilization. Do we have movable benches? Do we have green space that can be utilized? So, and then potentially even discuss renewable energy technologies. But we're not going to go into all those details today. We will strictly be sticking with the opportunities and specifics for heating and cooling. So let's start out with our heating options. And our heating options, we're going to start by looking at boilers. We'll talk some stuff about unit heaters. We're not going to talk too much about biomass, as biomass usually falls into the categories of either a biomass boiler or a biomass unit heater, such as a small pellet stove or something like that, that would be utilized similar to a unit heater inside the house itself. So a quick example of a boiler, we had a greenhouse that I had worked with in southeast Wisconsin. They had 4 houses they were looking to replace their boiler system with that wasn't able to keep up the season prior. And 2 of the 4 houses are used year-round. So using those the entire heating season makes them a good candidate usually to upgrade from a standard boiler, which is about 80% efficient, to a high-efficiency boiler. something along the lines of maybe a triangle tube, prestige, or solo, just something in that 95+% efficiency. And since these people were going to already be looking to replace boilers that couldn't keep up with something larger, this was a great opportunity to say, okay, we can stick with something as efficient as you have, or we can take that next step. So for them, sticking with that 80% efficient boiler was going to keep them at around $13,000 a year just for their heating costs. To go up to that higher efficiency boiler would be about 10,500 therms a year, about not quite $12,000. So we're looking at about a $1,500 savings. Now that we're looking at this as something they're going to do regardless one way or another, I looked at it as your incremental cost difference. How much extra was it to go from a standard boiler to this high efficiency? And for this facility, heating over 14,000 square feet of space was about $5,000. So based on incremental cost, we're looking at less than a 3.5-year payback. So for them, it was a very worthwhile option to look at and move forward with. Now, let's say they had the same greenhouse had a boiler that kept up just fine, and they were looking to completely replace it. Now our payback's going to be much more extended because they don't have to do anything. We're looking at the full cost of the piece of equipment. So now our payback's probably getting towards 9 or 10 years. But on a boiler that can last up to 20 years, that's not too bad, actually. Another thing that we can do when we're looking at boilers, other than saying, let's go to a higher efficiency option, is to make sure that the boiler that we have is working to its maximum capacity and best efficiency. And that may require a boiler tune-up. Usually I try to tell people to think about a boiler tune-up at least once every other year, preferably once a year. Have somebody who understands your system come out, check on the efficiency of it. How is it working? Is it operating properly? We can improve our consumption, reduce our consumption, which is to improve it by 10%, and then also increase the output, which would save energy, it saves money. Making sure that boiler tune-up is done plenty in advance can help make sure that we're not going to have those emergency outages in the middle of winter that can cost a lot when you have somebody come out on an emergency call to get it going, and hoping that our plants don't suffer in the process. And it extends the life of that heating equipment. So with boilers, we have options. Generally, boilers are used for in-floor or underbench heating, root zone heating. We can use these boilers to push out hot air. We can use them to push hot water. Generally, people are using them for hot water heating. And it can be along the perimeter of a greenhouse. It can be in the floor, in the concrete floor of a greenhouse. It can be right under the bench. Root zone heating is generally going to be bench heating or in-floor concrete heating that the plants are going right on the ground. And it's one of the most efficient ways to heat our greenhouses. We can generally lower our heating costs by up to 25%, increase yields of some of our crops that we're growing, and reduce our overall air temperatures. Once we've got those roots warmed up and heated up and happy, the outside air temperature can drop by up to 15 degrees. So we're not heating the greenhouse nearly as much, which is where most of our energy savings is coming from. But what's new with new root zone heating is I just found this recently. There's a new root zone heating system called an Aquathermat, or an Aquamat. Doesn't have the heating capacity, but an Aquathermat, actually, if you look at the picture here, you can see there's a kind of a soft material in the middle that would actually hold water through it, and there's a porous plastic cover on it. So the nice thing with this new option is not going to only save us heating costs, but it's actually going to save water, because this is actually also an irrigation system where the plants sit right on the mat, the heat tubes run through the mat, and the water runs through the mat, and it will wick up the water through capillary action. So as the plants need water, they draw it right up through that mat. So instead of having to irrigate, put extra tubing and piping, we've got kind of all in one. It's one of the newest ideas I've seen for root zone heating and saving water. As we all know, water is becoming a more and more scarce item depending on where you're located at, and we should all be trying our best to try to decrease our water consumption and save some for the next time we need it. So that's just something new I wanted to let people know about that I've seen recently, and it's pretty innovative. I know they did do something like this a few years ago with a company, and it didn't work well, but it seems the newer products coming out are working quite well for people. So underbench heating costs are really going to depend on, are we using a new boiler? Can we retrofit an existing system? We don't have to have a concrete floor, but it's really going to depend on how much is it going to cost. If we're starting from scratch with a whole brand new facility, that's the optimal time to try to put in a underbench or root zone heating system of some sort. We can pour it right into the concrete when we're getting everything poured and ready. Units on these boiler systems, our high efficiency, are going to be anywhere from $2,500 to $4,000, but that does not include installation. Payback anywhere from 6 to 8 years. Now, if we're retrofitting and all we have to do is add the tubing, because maybe we've already got a boiler system in place, we can bring that payback down because we don't need the whole system. We're just going to retrofit. But again, it's really going to depend on the facility, the size of the system that's going to be needed, and how are they currently set up, what kind of extra things do we need to add in. So an example here of a greenhouse that we worked with in the past, about 2,500 square foot Quonset type greenhouse, pretty standard sized greenhouse for most of our facilities. Needed about 350 million BTU when they had their current overhead heating system, which is pretty standard for most places. And then they wanted to switch to underbench, saving about 800 gallons of propane a year, which right now doesn't seem like a lot. Where most of us are anywhere between 68 cents and $1 per gallon this year. We got really low propane prices. However, a couple years ago when we were looking at $3 a gallon for propane, that starts to add up. So going from 350 to 275 million BTU of heat for one house alone, that can make a huge difference in if the grower is going to keep growing or if it's going to make them have to stop growing in the middle of winter. Let's move on to a quick discussion on unit heaters. We all know what unit heaters are. They're nice, they're quick to install. Everybody uses them because they're easy. They're the easiest thing. We can pop into a house and say, now we've got heat, we're ready to go. The thing to keep in mind with unit heaters is depending on where they're hung, it's going to change the distribution of our heat. So a lot of people hang them relatively high in the greenhouse, which is forcing that heat right down to the plant as well as heat rises. If we hang them a little bit lower, it gets that heat closer to the plant, it helps to actually get that heat around. And another thing to consider is we do the fan so that we can push that air down towards the plants and keep it rotating and circulating through the house. So unit heater efficiencies, we have 4 typical unit heaters. We've got our gravity vent unit heaters, which they actually are no longer making as of a few years ago. It was determined those were no longer allowed to be made. So the worst case scenario now we have is a power vented unit heater, which has taken our seasonal efficiency from 65% to almost 80%. So there are a lot of the gravity vented unit heaters still hanging around out there. Try to get people to get away from those as they fail instead of buying a used one that's the same. Then we've got our separated combustion unit heaters, and our newest high efficiency unit heaters are condensing unit heaters. Something to keep in mind is because the unit heater says it's an 80% thermal efficiency doesn't mean that that's what its true efficiency is going to be when we've got that heater hanging. The seasonal efficiency is going to take into account our heat loss and transfer from when that exhaust vent is on or off. It's also going to take into account any water that has to get boiled off of the system as the system is heating and having condensate land on the coils. So we really want to look at the seasonal efficiency. It's a much more effective or indicative indicator of how efficient is my system actually operating. Something else that we need to keep in mind is temperature control on any heating system that we use. They're very nice. They help us to automate the greenhouse. We won't heat and cool at the same time. They can be programmed to give us the optimal growing conditions. Some of these controllers can even be set up to work with a weather station and monitor weather activity. It'll help us know, should we be opening venting? Should we be closing venting? Should I be kicking up the temperature a little bit now? Does the temperature seem to be gaining outside? So a little bit more sophisticated, but does help to save energy. And it does usually have a relatively short payback, anywhere from 2 to 5 years. I've seen them even down under 1 year. So something everyone should be having instead of running in and out trying to change those controls themselves, or keeping the temperature the same all day, all night, every day regardless. So another thing that we can do with those temperature controls, like I said, is have it change day or night. so we might want it to be 70 degrees in the greenhouse during the day, but if we can drop that temperature by 5 degrees at night, we're looking at some really good energy savings. We get about 3% energy savings for every 1 degree we can reduce the temperature at night. So if we can keep it at 70 during the day and drop to 65 at night, that's a pretty good energy savings. Controls can save a lot of fuel oil in a year, 500 gallons in a 3,000 square foot greenhouse by dropping it by 5 degrees or so. We're going to quickly talk about refrigeration, just because there are some folks out there who do have refrigeration systems at their greenhouse. It may be strictly for storing produce. It may be for floral products. You never know what we've got depending on the grower. So when purchasing a refrigeration unit, we really want to look into not just how much is the cost of the unit, but how much is it going to cost to operate? How efficient is this unit? How good is the insulation in this unit? What kind of fuel source options do we have? And a 20-year-old refrigeration unit, if we get rid of it and put in a high-efficiency Energy Star unit, we could save up to 35% of our energy costs from that unit, which can be very significant. Maintenance on it would be very similar to what we're looking at for our boiler systems, for your home air conditioning systems, for a business air conditioning system. Want to make sure that it's working up to the best performance it can. Most refrigeration units have a 10-year life. However, we've all seen those units that have been sitting on site for anywhere from 20 to 30 years. Getting rid of those really old units to replace with a new one can have very low payback. And another thing that folks have an option to add on to these systems is electronically communicated motors, which work very well with evaporator fan controls. Now, we can't put in evaporator fan controls unless we've got the EC motors in there. The EC motors are what make the fan controls work. But most of those paybacks on the motors and the controls have a payback of less than a year, sometimes as little as 6 months. For a very low-cost option, we can save a decent amount of energy, anywhere from 10 to 15% is what I've found. So if we've got these refrigeration systems, we've got all these condensing units creating all this heat as it's trying to cool the refrigerator, which gives us another opportunity for saving heating costs. If we've got a facility that's using hot water heat, we can actually preheat that water with the waste heat from our refrigeration system and store it in what's called a refrigeration heat recovery unit. That heat recovery unit would then feed our water heater to decrease our water heating costs. Typically, a payback is going to be less than 5 years. I've seen them well under 2.5 years. And if we've got a facility with a lot of heating requirements, whether it's space heating or water heating needs, it can be a very, very good way to save energy and help us to decrease our costs and improve the bottom line. So now we are going to move on to our cooling section. If anyone has questions, as I've mentioned and Julia mentioned, please feel free to type it in. Otherwise, we're going to keep moving along and start our cooling section with a quick true-false question again. Since natural ventilation uses less energy when compared to mechanical fans, swamp coolers, misting, natural ventilation will always be a recommendation of a greenhouse energy audit. Hopefully all of you are thinking false, because it's really going to depend on each producer's unique operation needs and requirements. If we've got a house that does not have heat-tolerant plants, then just natural ventilation may not do it for us. If we've got one that has very heat-tolerant plants, then it may be a fantastic option for that grower. So let's get into a little bit more detail on our ventilation or cooling options for greenhouses. So do we even need cooling in a greenhouse? Generally, yes. People will need some sort of cooling in their greenhouse. Without any cooling, if we've got a 95-degree day, clear skies, sun is just shining down, inside that greenhouse could get well over 140 degrees. That is an extremely high heat-tolerant plant, such as a succulent, if you are going to let your plants get that hot. So we need some sort of mechanism to get some of that heat out of the greenhouse on those super hot days. What kind of options do we have? Well, we do have natural ventilation options. As you can see in the pictures, we've got roof venting, sidewall venting, and we've got mechanical ventilation. That may mean fans and louvers. That may mean pads and fans. When I say fans and pads, that is a swamp cooler. We've got fogging. We've got misting. So we've got lots of different options, and we'll kind of start with our natural ventilation and move from there. So natural ventilation is great because it's a very quiet greenhouse. We don't have all those fans running. It's little to no operating costs. It may increase our labor requirements and the labor costs if they are not automated systems, having somebody have to run in and out to open and close these things. And it really is going to be very dependent on our weather conditions. The temperature in the greenhouse, however, can be dropped by a significant amount, but it will still generally be higher by maybe 20 to 30 degrees than our outdoor temperature if all we have is natural ventilation. Now, again, if you've got a heat-tolerant crop, you're probably doing just fine. If you don't, you're going to need a little bit more than that. Natural ventilation is very, very good option for mild climates, but you also have to keep in mind that the greenhouse has to be situated in a specific position, in a specific way, so that that air does have the opportunity to flow. And another thing to keep in mind is we have to have vent area that's at least 15 to 30% of our floor area. You might think, oh, well, then I'll do even more than that and it'll be better. Actually, studies have found that going over that 30% of floor area has not proven to increase our cooling. So if we get to that 30%, it kind of maximizes that natural ventilation system, but we do want to get at least 15% so we have enough airflow to move the air through and to cool it and get rid of that hot air. So the options are we've got ridge vents and sidewall vents. We also have roll-up sidewalls, so they don't have to be a louvered type system. The ridge and sidewall vents really have to work together. If you put in a ridge vent without a sidewall vent, we're not going to get much airflow. The whole premise on using ridge vents is that the sidewall vents allow cooler air to move through the house and the hot air to escape out of the top. So it's really a cycle of air flowing through the sides and up through the top to create that chimney effect and get the hot air out. We can just do it with sidewalls as well. Now the thing again with sidewalls is we need enough space between our houses that there's an actual enough airflow to go through that house and get our air changes per hour that we're hoping to get. These systems can be mechanized. They can be done manually. The mechanization is actually very low cost, pretty minimal amount of energy used to move those motors to get those ridge vents or sidewalls to open. So here's a quick example of our ridge vents or our natural ventilation. Typical size greenhouse, 128 by 30 feet, Quonset type house. Originally they had two 48-inch fans, 1 horsepower fans, that would run anytime the temperature was 75 degrees or higher. And this was another Wisconsin, down towards Milwaukee, down towards the lake, so they had a little bit cooler temperatures with that lake effect. And they said what would happen if we decided to put in natural ventilation, which would require now 4 motors. How much do they run? Pretty minimal. $145 a year savings just by taking how many hours a year our 2 1-horsepower fans are going to run versus the amount of time our natural ventilation little bitty roll-up curtain motors were going to run. So let's move into some mechanical cooling. We'll start with our fans and move into our swamp coolers, fogging and misting. Everything generally works a little bit better with a shade cloth. That's an option for everyone, but we'll get into a little more detail here. So fans and louvers are pretty standard, typical setup when we look at a cooling system in a greenhouse if they're not using ventilation. Generally, our indoor temperature will be within 10 degrees of outdoor temperature if the system is set up and sized properly. We're trying to get a full air volume per minute of air change through that greenhouse. Our louvers have to be bigger than our fans so we can pull enough air through to get that full air change per minute. Most greenhouses, regardless of if they're doing natural ventilation, will have some sort of fan and louver. They're generally using it, if they're using natural ventilation, as a winter means to get excess heat and moisture out of the greenhouse so it doesn't get too humid and too damp in there. But a lot of greenhouses do use it for cooling. They've got those crops that are not very heat tolerant and they need to get that air temperature down. The nice thing about fans and louvers compared to natural ventilation is we have a lot of control over our air intake and our exhaust. We can put on VFDs, we can put on multi-speed fans to say we want more or less air movement. And if we do proper maintenance on our fans, we can actually save energy anywhere from 10 to 20%. Are our louvers opening and closing properly, fully and closing tightly? Are fan belts tight? Does everything seem to be in proper working order? Are there birds' nests inside of these fans? Is everything clear and working right? So something to make sure we do annually is check our fans to make sure they're operating at their full potential. Adding in a shade cloth to our fans and louvers can actually bring us to within a couple of degrees of outside temperature, which that shade cloth can be inside the greenhouse, suspended from wires. It can be thrown over the top of the greenhouse as needed. A lot of times we're going to use that shade cloth also as a thermal curtain. Our thermal curtains are rated at a % shading so that you can get a 2-in-1 effect, save heating and saving cooling energy. Pads and fans. Pads and fans are what we would generally call a swamp cooler setup, where we've got fans on one side of the greenhouse and a pad system at the other end. Cold water flows through that pad system, and as those exhaust fans pull air through, the air comes through the pad, cooled with water, and we get an evaporative cooling effect. Cool air comes into the house, hot air exhausted out. Again, using a shade cloth for these systems will increase the efficiency of the system and increase our cooling capacity. Generally, we can get our temperatures in the greenhouse to 10 to 15 degrees cooler than our outdoor temperature. They will cost more money to operate, but if you have a crop that needs that cooler temperature, this is a really good option to use. Another option that we can use is misting, fogging, sprinklers, those kinds of things. In comparison to using fans with pads, it's a very quiet operation. So people really like to use these things so that it's not so loud in the greenhouse, especially if it's a house that we've got customers walking through and they want to be able to hear and to talk and to look at different things without all that wind running across them. They can be used pulsed on and off to get a fine degree of, very, very fine degree of evaporative cooling. And it gets a nice temperature balance. This will actually be able to get us even cooler than a swamp cooler will, depending on the system that you use. So if we use a low pressure fogging or misting system, we do have potential problems. Could be clogging from impurities in the water. That puts a lot of water on the foliage in the greenhouse, which could lead to different funguses, diseases, things like that. It will leave mineral deposits on the crops. So the smaller the particle size, the more even the distribution, the less chance of problems with our foliage. So low pressure systems are generally a larger water droplet, and it's typically advantageous to look at more of a high pressure fogging system. These systems produce extremely small droplets of water and can actually reduce our temperatures in the greenhouse by up to 25 degrees below outside temperature. Excuse me. Studies from North Carolina State University Ag Extension have found that we can get 28% greater cooling efficiency than using a low pressure system, and the evaporation efficiency is 2/3 greater than a low pressure system. So using these tiny, tiny droplets can actually give us a lot better cooling and a lot more efficiency. Now, something to keep in mind is these are 500 PSI systems to create these fine droplets. They're very high pressure. You're going to need a high pressure pump. You're going to likely need water purification systems if you're pulling groundwater right out of a well or a pond. You need high pressure lines that can handle these systems. So it will be a much more expensive system than looking at using a swamp cooler or using a high pressure system. But again, depending on the crop you're growing, it may be worth it. And if you're going to look at some kind of fogging or misting system, this is a lot more efficient than those low pressure systems are, especially when it comes to the cooling side. So we need to make sure that we maximize our evaporative cooling efficiency. We've got options to do that. We can use swamp coolers, the fan and pad system. We need to make sure we have a well-sealed building, and it's going to force that air from one end to the other. If we're going to use that system, we want to make sure we use high-efficiency fans. We have very good controls, staging, variable frequency drives are an option for those fans, and maintaining those fans are really important. We're moving into using fogging, misting, sprinkler systems, something like that. Make sure that pump is a high-efficiency pump. Make sure we've got the proper maintenance on those systems. Make sure we've got water filtration systems so we can prevent clogging and we can prevent mineral deposits on our leaves. And something else that we can always do is, if people are looking at renewable energy, is can we run these pumps, these motors, these fans on maybe a solar thermal or a solar electric system? Not solar thermal, but solar electric. So just some options out there, just a quick recap for everybody. So what are, see, I had a slide in there 2 times, apologize for that. Some of the funding opportunities. Now, depending on the type of business you are you agriculture, are you commercial, are you considered industrial? There may be some business incentives out there. There may be rural programs. There may be utility type programs. Some of the funding options people may want to think about or look at is, does your local utility for gas or electric offer energy efficiency incentives? Does your state have a program that offers incentives? USDA Rural Energy for America program may work for you if you're looking at a system. NRCS EQIP may be an option. So you really want to look at all the options available. Talk to your USDA person, talk to your NRCS rep, talk to your utility program, talk to the state programs, see what's out there, see if anything has a potential incentive to help bring down some of the paybacks on some of these projects and make them more realistic to actually go ahead and get them installed. So that wraps up our presentation. We do have plenty of time for any questions and answers if folks want to put them out there. This program or this webinar will be posted. Julia will get that up and online. So if anybody wants to look through it again, wants to listen again, just shoot an email over to Julia with your contact information and she'll send it out. I'm guessing she will also send out a general email to everyone letting you know when the webinar is posted and the link to it as well. So in the chat box, go ahead and ask any questions, and we'll stay on for just a couple minutes here yet so you guys can get your questions answered. Otherwise, I do want to say thank you to everyone who jumped on today. We will be doing more webinars in the next few months, and we will alert everybody to the new webinars as they come up.
All right, I don't think I am seeing anything come through. We want to be very conscious of your time. So again, like Bethany said, I thank you so much for spending your morning with us for a little bit today. If you are interested, or if somebody else might be interested in the webinar, go ahead and feel free to email me, and I will get you the link as soon as it is available. And again, thank you so much for participating today, and have a great morning.